Imagine a dancer gracefully moving across a stage, or a perfectly executed dive into a pool. What underlies these elegant movements? The answer, in part, lies in the principles of kinematics. Kinematics, at its core, is the study of motion without considering the forces that cause it. And it is also true for your robot partner. It's the pure geometry of movement, the choreography of points and angles through space and time. However, to understand kinematics, we must first grasp its fundamental concepts. So let's get into today's topic.
Before we proceed, let me tell you one thing. If you have not subscribed yet, please subscribe. It means a lot to me. And if you have already subscribed, tons of thanks for your support.
Let's start with displacement, which is the change in position of an object. Then, there's velocity, the rate of change of displacement, telling us how fast an object is moving and in what direction. And finally, acceleration, the rate of change of velocity, which reveals how the speed and direction of motion are changing. These concepts are not mere abstractions. They are the building blocks of understanding how any object, be it a falling apple or a complex robotic arm, moves through its environment. To illustrate, consider a simple linear motion, a train traveling along a straight track. We can describe its displacement by how far it has traveled from its starting point, its velocity by its speed and direction, and its acceleration by how quickly it speeds up or slows down. Now, let's move beyond linear motion to the more intricate world of rotational motion. Here, we encounter angular displacement. It is the change in angle of a rotating object. Then comes angular velocity, the rate of change of angular displacement. And after that comes angular acceleration, which is the rate of change of angular velocity. Think of a spinning top. Its angular velocity tells us how fast it's rotating. Besides, its angular acceleration reveals whether it's speeding up or slowing down. As an outcome, the true power of kinematics is revealed when we delve into complex motions, especially in the context of robotic systems. In robotics, kinematics is not just a theoretical exercise. It's the very foundation upon which robot movement is built. Forward kinematics, for instance, is the process of determining the position and orientation of a robot's end effector. You can think of its hand, tool, or any point of interest which is based on the angles of its joints. This is crucial for tasks like precise pick-and-place operations. Consequently, it is important for any type of physical activity that we can imagine. Therefore, imagine a robotic arm assembling components on a production line. By knowing the angles of each joint, engineers can calculate exactly where the arm's gripper will be in space, ensuring accurate placement. Inverse kinematics, on the other hand, is the opposite problem. Given a desired position and orientation of the end effector, we need to calculate the necessary joint angles. This is a far more challenging task, often involving complex mathematical equations and multiple possible solutions. Consider a humanoid robot reaching for a doorknob of your room. We need to determine the precise joint angles of its arm and shoulder to achieve the desired hand position. Inverse kinematics allows us to solve this problem, enabling the robot to perform complex, goal-oriented movements. The application of kinematics extends beyond simple positioning. Trajectory planning, for example, involves calculating a smooth and efficient path for a robot to follow. This is vital for tasks like autonomous navigation or robotic welding, where precise control over the robot's motion is essential. By carefully planning the robot's trajectory, we can minimize vibrations, reduce energy consumption, and ensure smooth, continuous movement. Furthermore, kinematic singularities are points in a robot's workspace where it loses one or more degrees of freedom. These singularities can cause sudden changes in joint velocities or even prevent the robot from reaching certain positions. Understanding and avoiding these singularities is crucial for designing safe and reliable robotic systems. For instance, a robot operating in a confined space might encounter singularities if its arm is extended too far or positioned at an awkward angle. In the realm of humanoid robotics, kinematics takes on an even greater significance. Keeping these things in mind, can we equate robots' movement with human movement? Because human movement is incredibly complex, it involves a multitude of joints and degrees of freedom. To replicate this, humanoid robots must be designed with intricate kinematic structures. By studying human biomechanics and applying kinematic principles, engineers can create robots that walk, run, and perform complex manipulations with a degree of naturalness. And of course, without which your robot partner cannot do any physical activity along with you. Leaving aside all very difficult tasks that involve physical movement, as an intelligent person you can understand what I am hinting at. On the contrary, just consider the challenge of making a humanoid robot walk. Each step involves a complex sequence of joint movements, requiring precise coordination and timing. Kinematic analysis allows us to break down this movement into its constituent parts. Why? Because it calculates the necessary joint angles and velocities to achieve a stable and efficient gait. Furthermore, kinematic models are crucial in simulating and predicting the movement of the robot before it is built, saving time and resources. Therefore, kinematics is the language of motion. Not only that, it is the fundamental framework upon which we understand and control movement. From the simple trajectory of a ball to the complex choreography of a humanoid robot has many things to do. Actually, kinematics provides the tools and concepts necessary to analyze, predict, and manipulate motion. It is the invisible hand that guides robotic movement, enabling machines to perform tasks with precision, efficiency, and grace. As robotic technology continues to advance, the importance of kinematics will only grow. It will shape the future of automation and human-machine interaction. Thank you for joining us on this journey. Let's continue this conversation in the comments below. If you like the video, please hit the bell icon to get notified and don't forget to like, share, and subscribe for more insights. See you in the next video. Till then, goodbye, take care, and stay safe.